Operating system kernel info leaks are a major security issue. By exploiting info leaks, an attacker can leak sensitive data such as crypto keys or circumvent defenses such as kernel address space layout randomization. We present kMVX, a multivariate execution-based approach to prevent info leaks in the operating system kernel. Prior defenses against info leaks usually focus on one single class of bugs, such as uninitialized reads or out-of-bound reads. We present kMVX, a blanket mitigation against kernel info leaks caused by various classes of bugs. By running the same operation on two diversified kernels on the same hardware, we're able to detect divergences caused by exploitation attempts. Our design consists of three major components. The first component, the syscall sync, checks for consistency between the kernels at the kernel user space boundary. The second component, I/O sync, gives both kernels a uniform view of shared hardware resources and other stateful systems, such as the network stack. In this scheme, the leader kernel communicates with hardware and replays the results to the follower kernel. The third component, variant generation, creates diversified kernels at compile time, for example, ensuring that the memory layout is different between variants. We utilize strategies such as disjoint address spaces, stack layout randomization, and heap allocator variation to achieve diversity in the kernel. Due to the diversification strategies, exploitation for info leaks will leak different data, allowing us to detect this divergence. We implemented our kMVX prototype on top of Linux, keeping the full Linux API compatibility even for multi-thread applications. For compatibility, we support two modes of subsystem replication, allowing us to easily keep I/O consistency between the variants using a high-level subsystem replication, while also allowing us to run as much diversified code in both variants using a low-level replication mechanism. We achieve this blanket kernel info leak mitigation at a runtime overhead of 20 to 50%. If this all interests you, please join us at Security Session 3 at ASPLOS for more details on kMVX.